Students, let's look at this question here, which is hypothesis testing. Let's say I'm going to do this proficiently. So a sample of 80 light bulbs is taken from a population with a mean lifetime of 1,500 hours. The lifetime X hours of each light bulb was recorded as follows. A statistical test is carried out at 8% level of significance, and it is found that the population mean lifetime is not 1,500. So say what you understand by expression 8% level of significance in the context of the question. So level of significance is essentially if you are telling the truth, what's the chance that I'm gonna say that you're lying? Okay. So generally what we want is that to be lesser the better. So meaning to say I have a lesser chance of saying that you're a liar, pants on fire, when you're actually telling the truth. So in this case here, you have 8% chance of saying that the mean lifetime is 1,500 hours when it's indeed 1,500 hours. So just write it down. So this is right. You must write that the claim rejecting the claim. So you reject the claim that the lifetime is 1,500 when it's actually telling the truth. This is rejecting H naught. Then when to be given that H naught is true. Okay, so that's the idea there. So let's look at part 2. Find the range of level of significance at which the test will indicate the population mean lifetime is not 1,000. So in this case, you need to use CLT because they did not say that the population is normally distributed. But the good thing is you have 80 light bulbs. So by central limit theorem, the sample mean will just be approximately normal. So write it down. H naught will be because you claim to be 1,500 hours, right? Okay. So this case here, the alternate hypothesis has to be two-tailed, right? Because you claim to be 1,500 hours, but the problem now is you do not want to over promise or under promise. Okay, so you just need to make sure it's on the dot 1,500 hours. So in this case, I'm going to write down everything down. So if n is 80 light bulbs, so you have 80 light bulbs in the sample, and after which we have a summation of x and so on. So we need to find the unbiased estimate population variance as well. So this is a S square, but we want the unbiased estimate population standard deviation. So now we write down under H naught test statistic. Right. In this case here, we need to use the rejection zone method, which is the classical method, because we need to find the range of level. Oh, actually p-value. Oh no, we just use p-value. Okay. So if you want the range of level of significance, then you just use p-value. So let's look at that. Okay. So this is it. Approximated by central limit theorem. Then after which, what we need to do is just just find the p-value, then we just find the range of alpha. So this case here, just go to test, z-test, then I'm gonna just put in mu naught, which is actually 1,500, huge value. Sigma will just be 5392. It's actually the root of this guy, so 0.118. The x bar would be 1377.5. Then after which we have got this is 80, then not two-tailed, then we're just going to find the p-value. So essentially we want to find the range of p-value. So the test here, we're not testing on the alpha percentage here, so my bad. So this is just n80. Okay, we just find from calculator. You need to write by central limit theorem. Okay, so from GC, sorry, I wrote wrongly the formula, so let me just mark it down. So I wrote wrongly the formula. This is 1 over n minus 1. So this is because the reason why I know it's wrong is because p-value was 80%. So something may have like gone wrong, right? So just take note of that. So this p-value is 6.914%. So basically you want the range where the population mean lifetime is not 1,500 hours. So meaning to say we want to support H1, right? So reject H naught then. Rejecting H naught just means that p-value have to be less than level of significance. Okay. So level of significance, usually we write in percentage points. So 0.91%. So this is 6.91%. 6.1% 3SF. Okay. So that's how you do this question here proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.